Hi everyone. Today we are going to explore Neo4J databases. Neo4J is a company which is a pioneer in database, graph database. So this is the company website. This is the first landing page which you get once you Google Neo4J. Um, so let's just start the discussion by a brief introduction on graph databases, what graph database is. So graph database it stores nodes and relationships instead of tables and documents. So you have your traditional databases like SQL database, which store an entity and its relation in tabular format. It will have its attributes in the columns and records in the row format. Or you also have document DBs, which store XMLs and other JSON format of data. Another database, which is graph database, what it does, it stores the relationship between the two entities in the form of the edges and the entity itself in the form of nodes. So as you can see here, suppose this is one person or this is one entity. We can store it as, you can store all its attributes like name, when was he born, what is his Twitter address, etc., as one entity, as one node into graph database. And similarly, you will have another entity, a different person, and the relationship between them, like followers, followee, etc., can be stored as these edges of the graphs. It can also extend into a different entity, their connection with a total third entity altogether. Maybe this is a car or a company where they work together, or a particular product which they favor more. So all these things can be represented in graph format and can be stored as it is in a graph database. um, you can learn about more industrial applications from the Neo4 website itself. So if you come here, you have multiple sub menu over here, like products, use case, developers and data scientists, pricing. If you want to learn something, you have a resource library over here and other community websites over here. So if you come here under use cases, industries and use cases, you'll find that graph database can be used for a lot of analytical works, a lot of network and database infrastructure monitoring, because it makes it easy to understand how different databases and how different APIs are connected to each other. If one service goes down or if a Docker fails, how it is going to impact the entire network systems. Um, Social media, as I mentioned, is another place wherein it is easy to comprehend the relationship between two entities. Suppose, for example, you have Instagram. So you have two people, one who follows and the other who's following. So you can understand how different posts and how different reels flow from one particular source to it reaches your feed. So in order to understand the flow of information through the graph, this particular database design can help you easily identify. Same thing happens in supply chain management, wherein you have different components in a product life cycle, and you want to visualize or store the information. There are so many informations from different components, like you have ledgers, you have companies, you have shareholders, stakeholders, etc. So this graph db makes it more easy to have multiple levels and multiple entities come together and form the entire big picture. So the flow of information is more easy in graph database. Okay, so coming back to the company website, the company has two products, Neo4j Graph Database and Neo4j Aura DB. So what we are going to do is, in this particular tutorial, we are going to explore more on Neo4j Aura DB. It's free, so you can just sign in and do some of the experiments and some of the tutorials side by side. So let's just start the free trial. You can click here and then it will take you to the sign up page wherein you can log in through your Google account. Okay, so this is the page right after you log into the account. Let me just use it so I could change the tab. Yeah. All right. So there are two versions. One is free, which gives you memory of 1 GB, the graph size of 20 to 100K nodes, 400K relationships, and it gets inactive in 3 days. Okay, it is a GCP, so Google Cloud provider. Uh, this is a cloud provider option, Google Cloud platform. With the professional one, you have 64 GB and you have unlimited graph size. More for the industrial use, and it supports Google Cloud Platform, AWS, and Azure. So I'll just go for create free instance, and you get this username. So you just copy this just to make it handy somewhere, and just keep it, download and continue. So you have already downloaded the credentials. You get a tutorial. You select for what purpose you are using it, and you just get the developer role, and you're good to start. Okay, so it takes time to create a new instance. So you see this instance has started running. This is the node relationship. All the counts are here. Where is your Google Cloud hosted? It is hosted in Singapore, Asia Southeast. And what is the connection URL? Everything. You get the entire description of the instance running over here. I'll also show you the text file which got downloaded earlier. So this is the text file which has your username, URI, password, instances, etc. All these details. It will come handy once you start integrating it with a CMD, or later in stages once you want to delete any database or reinitiate any database. This will come handy. All right, coming back to our instance. Once we have created an instance, we can just go and open it. So it will open a workspace for us. So you just accept the terms and condition. And here you can enter the schema. So it has two schema supports. One is Neo4J plus S, and the other is Bolt. You have the connection URL, which is pre-filled. So you can just keep a note of this connection URL. If you want to integrate it with your APIs or any other services, web services, you would want to, keep this handy for integration in later stage. So you have a database user. So this is your user, and you have to create a password for it. So any classic JDBC connection details, these are those connection details. You have schema, you have connection URL, the user, and the password. So I'll just open this file again. So you can see I would like to create the parallel between these two. So you have 615.240.8a A8. So you have the same URL over here. It is followed by Neo4J plus S 615.240.A8. Okay, so this is the URL. This is the same username, Neo4J, and then you have this password. So you just have to take this particular password and you have to fill it over here. This information again comes in highlighted that says username and password are stored in the file that you downloaded when you created this instance. So you are connecting to the instance. Post that, you get a couple of guides. So this is like the beginner's guide, how to import data, how to export data, and some fundamental queries. So we can just refer to these in order to understand the basics and how Neo4j databases actually work.
So after you have initiated the database connection, you will be asked to go through a couple of user guides and some help and tips around this particular platform. So this is your Neo4j workspace. Basically, it has three sub tabs. So you see here there is an explore, there is query, and import. So we'll go one by one into each of them. So as the word import says, here you're going to place all your nodes and all the relationships, you're going to make it over here. And after you have done a particular entity relationship model, after you have established over here, you can easily upload the data using CSV or TSV over here. So just to make it more user friendly, they have given a couple of options over here to directly add note using the graphical interface itself. So I'm just going to click over here that says add a note label, and you can write the name of the node over here, like suppose I say product. So this becomes my node. Now in your right hand side you will see the label of that particular node, and you can add the properties over here, like what are the names of the attributes. Suppose I write it over here product ID, and it is a string. So this becomes your primary key. Until unless you have added more, this by default will be a primary key. You can switch between the keys over here. So suppose second attribute I give as quantity, which is a integer, float, boolean. These are the types, data types of a particular field. So I'll just write over here integer. Okay, so with this you get to know these are the two attributes this particular node holds. Similarly, you can add another node. Let's call this company and have properties like company name, and one more, suppose the pin code. Now in order to establish a relationship, you just hover over this to a gray circle and drag it directly. And if you want to name this particular relationship, you can just write it over here what the relationship name or label is. Suppose let's call it produced or manufactured by. And you can have, just like an entity relationship model which we made, you can have its own property. So this particular manufactured by can have its own attributes. Suppose I just say product code or date of manufacturing. Date of manufacturing, and it can be string or date time. So this is something which you can write. You can even reverse the direction, like if product is manufactured by company makes this product, so you can reverse the direction based on the labels over here. Okay. Similarly, if you want to delete something, like suppose you have made a particular node, also before we go to that, every relationship should start from a node and should end on a node. So you cannot have a relationship starting but never ending on a node. Okay, so if you just make a node over here like this, suppose customer, but then later on you realize that you do not need it anymore, so you can just click on that particular node and delete it. If you want to have something like a self loop over here, like you have customers who are also clients, then you can just double click and you will have a self loop over here. So I quickly added in product these properties: product ID, quantity, and product name. The company has company name and PIN code, and manufactured by this relation has a date of manufacturing, product ID, and company name. Okay, so once we have done this particular node development and the relationship and company, what we need is we need to populate these nodes with the appropriate data. So the two formats in which this particular Neo4J accepts data is CSV and TSV. So we'll go with CSV format. So here I have made CSVs for the three tables, that is company, manufacturing, and product. So just to give you a glimpse of how the data looks, it has product ID, quantity, and product name. These headers need not be the same as your column names or the attributes over here what you have given, because later on you will get an opportunity to map it from these files, the columns, to the actual attributes in the node. Okay, so product ID, quantity, and product name, this is for the product table. Then you have a similar thing for manufacturing, which is the manufacturing date, the product, and company. So here you have to be careful for one thing. The date time format for Neo4J nodes are a little different. So it follows a convention of year, month, and date. So you require to change it into that format before import. Okay. And a similar effort was done for company as well. So we have two companies, ABC and PQR, and you have their corresponding products and the manufacturing date in the manufacturing table. Now what I'll do is I'll quickly browse, select these three CSVs, and you get here a few snapshots of how the data looks. Okay, once this has been uploaded, you will start seeing the option of file which was earlier not present over there. Right, so if I delete it, if I remove it, and if I go to company, uh, let me just remove everything first. You will not see, as you can see, that option of file to the product or the property mapping has disappeared. So what you need to do is, once you upload the files, you will get an opportunity to map these columns, from which file which column represents what attribute or what property. So for company, as you see, company CSV, you have company name, same as company name. So see, here it is COMP name, here it is company name. So you the names in the CSV need not be same as the attributes or the properties of the node. Okay, then you go to product. If you try and do run import with only one mapping, it will throw an error. So I'll show you. So you see your data model has an error. So you need to resolve these errors. So if you have like 10 different nodes or 10 different tables, you need to import all the CSVs for all the 10 different tables in one go before you can run the import. So if the product is coupled to product ID, quantity, and product name. And for manufacturing, you get manufacturing.csv. Here you'll have to specify that from product table, product ID is associated with which column of this particular relation. So product ID is associated with product column. Company name is associated with company column. And here from the file, what information are you getting? So this is from the table, the parent tables, and this is the information which you are getting from the import file. Okay, now I'll just do a run import, and here I'll get a um, summary of what all has happened, which all properties have been updated, how many rows have been updated. So as you can see, there are 12 records in my CSV. Let me quickly take you there. So for product table, you have 12 records. So all those 12 records have been successfully updated over here. Uh, and for company, you have two companies, that is ABC and PQR. So that has been updated. And for manufacturing, again the relation, there are 12 which set the manufacturing date of different products. You can also see the ciphers. So this is the language in which Neo4j codes. So this is the create constraints or the queries. You can find it over here, as to how this particular, so we are in company again. So you have a unique key called the company name. So it implements the SQL query to create that particular constraint. And then just like how we import or how we insert the records, it has a load statement. So it has a create statement, it has a load statement. So this is the language in which you can code your ciphers, or what you can say the queries. Okay, after this we'll just go and explore the result. So again, as we had two companies, you can see here there are the pink color, it resembles the company, and the yellow color, it resembles the product. So there are two companies and 12 products. You can also put in filters over here. You can have a slicer which will be a subset of the entire graph. Um, Also, once you click on a particular node, it will give you the information like what is the company name and the pin code. Okay. You can explore the neighbors. So this particular node has supposedly 6 neighbors, okay, 6 products associated with it. So as you can see, this particular company has 6 products, 1, 2, 3, 4, 5, and 6. So it shows all the neighbors and the relationship that is manufactured by. So it combines that ABC manufactures ABC hand wash, and this is the manufacturing date, this is the product, this is the company. So you can see everything in detail over here under relationships. Okay. Once you click on the relationship, it again gives a summary, but from the viewpoint of a relation that is manufactured by. So it has two different entities, product and company, and how are these two connected. It gives a summary in that essence. So the date on which it was created, that is a unique attribute pertaining to the relation. This particular attribute is neither with company nor with product, it is exclusively with the relationship. So you can get that information by clicking on the relationship itself. And the node, again, the properties of product, you can find it here. The neighboring, which is like these all, this particular product is coupled with ABC company, and there is a manufactured by relationship. So as you can see, these two companies, they are not connected amongst themselves. So you can have a loop connection in company, and then you can probably say ABC is a parent of PQR and vice versa. So if you want to establish that relation, you can have a self loop connecting ABC and PQR.
So we have gone through this particular Explore tab. We've also seen how to import the data. So first create the two nodes or the tables for your analysis and establish the relationship between each table and then select the files to import the data. Now, in the Explore, this particular tool Neo4J has given, which is very company friendly. So you can just go and use some of the default functions over here called filters and slices to get a overview of how these particular graphs and how these tables are statistically distributed and what are the visual insights you can get from this particular graph. So it is very visually handy tool over here. So let's just explore what filter does. So you're given an option to add a filter. You can anytime define the name of this particular filter. So I'll just say I would like to, filter it on company. So in company, you have company name and PIN code. So suppose I want to filter it using company name. I'll just select ABC and then apply the filter. And you see ABC is the only company that is highlighted over here. The PQR one, it get diminished. Okay. You can also add a filter wherein you can add it on product level and then say, I just want to, because there is already an existing filter over here of ABC, it shows only the options of ABC over here. And supposedly I just want to filter it on quantity. So you see, you get a good map of how different, quantities are spread on a histogram. Okay, then you can select the range which you want to visualize. Suppose I want to just see the high quantity products only. So I'll just apply a filter over here and then only those bubbles are the ones which are highlighted. And the rest are, those bubbles which even from the PQR company, only the products which have high quantity are shown over here. The products which have lesser quantity are diminished. Now, this is how a filter works. If you want to delete a particular filter, you can simply put in a delete over here. Okay. Now, the other one is slicer. It gives the ranges, any quantity which has a range attribute like quantity, like manufacturing date, something which you can put it on a range. Those attributes are displayed over here. So you don't have to uh, go and individually find the attributes on which you can apply ranges. Um, if suppose there are 50 odd attributes or 50 odd tables over here, all the attributes corresponding to the range will be present here in the drop down. So here again, it is, as I mentioned, it is very user friendly and you can use the graphic interface itself to select the range. So you can just use the slider to slide what is the quantity range that you want to observe. And again, only those ranges are visible on the graph workspace. The others are deleted. If you want to add another range by date, so again, here from this particular portion also you can get good visual inferences around which time are the products usually manufactured and how many relationships are there corresponding to those particular times. So you can say there are two relationships or there are two products manufactured on 31st of October, something like that. So you can just select the range and then as you can see the products and the companies, those relationships are shown over here which corresponds to these two slicers. Okay, so this is for the slicers and filters. deselect it. The third tab, which gives you the information about the database, are you know, the database nodes and relationships is the query. So this particular tab, it says how many nodes or how many tables you have. So you have company node and product node. Again, as you click, it shows a graphical representation. You can even translate it into table format, like what are the attributes, company name and pin code. These are the two attributes corresponding to company. So you can have a tabular format. You can have a raw version over here, which has, summaries and query types in a JSON format. Okay. So this is something which is again visually very easy to comprehend. You have relationships. So here you can see how different relationships are mapped. You can have a tabular format again for these relationships and a raw format. There's something called property keys over here. So you will have the entities and the companies. So it is a relationship, and what is the value of that particular relationship, you can see over here. Okay. Again, whatever you can do in the Explore tab, you can do here as well. So if you just double click on a particular company, you can see how different other entities are connected to this particular node, this company node. So you can just see, visualize how PQR has these different products over here. So the advantage of this is you don't have to write long queries, do a lot of joins, and then comprehend a particular result, or achieve a particular result from different tables. That thing can be easily done through just clicking a few of the icons over here, and you will be able to get a visually comprehensible images over here, and you can take the decisions as per your desired query. All right, with this, it brings us to the last section of query tab, that is your ciphers. So as you can see, what you get over here is a kind of cipher. So you don't have to write the long joins, as I mentioned earlier. The syntax is very different from the SQL syntax. So suppose if you want to find a company with the name PQR, and what you have to do is write the statement like match, tch match. Then this is the variable that will be used in place of company. And inside this, you have to mention that you need a company name, suppose like PQR. Okay, you're looking for this particular company and you want to return n, and you limit the output to 25, the top 25 companies. So as you can see here, there are only two companies, ABC and PQR. I'm expecting only PQR to be shown. So when I run this, sorry, the spelling. Right. So as you can see here, you get just one output, that is PQR. All right. Once you have this particular query, you can save it using the Save tab. So you have an option to rename what your query is. Suppose I rename it as my first cipher and put it in a new folder called cipher. So you can come and edit over here what the name of the new folder should be. Suppose first cipher is the name of the folder, and you can say this is my first cipher. Also, you can delete if there is any existing folder from here. So this is the way you can maintain the library of folders and ciphers which you have already used, and avoid rewriting ciphers again and again for your analysis. All right, so with this, we come to an end of all the tabs and all the UI exploration of Neo4j. Hope this was informative enough. Thank you.